You're right. Let's see. Just make sure my audio works. Yeah. Okay, so I'm noticing I'm a bit tired. Uh, but I was watching this Task Gen video, and again, like really amazing insights and everything, and it just inspired me. So I wanted to play around, play around with something, because if we think about the way I'm doing the agents now, I'm building up these agents, and they're quite like verbose. And I'm building up this agents router, and I have like this complicated flow. And I was thinking about like a very different architecture, inspired from that video. And I think I can best express this as like just writing code. So what I was thinking is like, what if we kind of think of the conversation with the agent as the context of the agent. But what if the context of the agent isn't the conversation? It is it's like tasks. So what I mean is, yeah, what do I mean? So what if you have an agent you can just call? So in your application code, you will say something like, let's see. Yeah, it's just a function. Well, could it be just a function? Yeah. So you would say, like, there's some initial agent, some agent, and you would call it, and it will probably take like some prompt, and then what you would do is you would await the response of that agent. Let's put it in a async main function. And what you could do is that you could check the state of the agent. So it would give you a result. So imagine that calling this sum agent would result in like performing multiple steps, multiple tasks. And when those tasks are done, or one of them errors, or one of them requires more feedback from the user, you will get a response here. Yeah, I'm not sure if it should be like a promise. You just call the agent, and then you have like agent on completed. You have something for that. Agent on our agent on task completed. Blah blah blah. And like agent on task error, whatever. Oh, sorry. And like agent on task started. So you could like track its progress. And agent on requires like on halted or something. I don't know. It requires input from the user. On stalled. And it will require some input from a user. And the point is, you create this agent by create agent, And then some agent equals create agent. And when you create this agent, it should be as minimal as possible. So I kind of been thinking about like the full spectrum of what's needed to actually write code for a web application and validate it and everything. But what if we flip the perspective? So how can you just, instead of having like 5 concrete flows, 5 concrete agents within those flows, what if you just start at the beginning? There's a question coming from a user, and then you give that initial agent some capabilities. And those capabilities are function calls. That's how it performs something. And based on the function calls it has, it can create a task list. So we can just ask it, what are your next steps? And it will create the task list based on the function calls it has, its capabilities. And then on those function calls, you'll go and either actually do something in the app, but you can also go and call another agent. And doing so, I think it's way easier to iterate. Because if you do that, you just start with this one agent and then you just prompt it and it will say, I don't know what to do with this because it doesn't have any functions. It can't do anything. And then you add a function to act on that prompt. And that could be calling a different agent. And that other agent requires a certain input to operate, that being the prompt or whatever. And then it will do exactly the same. Based on its functions, it will evaluate what are my next steps. And it will start calling this function, like propagate up what it's doing. Yeah. And then to make it smarter, it's only about adding functions. Those functions being actual like function calls in the app or being calling a different agent, it doesn't matter. Because what I like about this is that we just discovered that with Llama Index, we got like this other agent that's not part of the agents router. So it's like a function, right? So just to kind of emphasize what I mean here, it could still have, like, it doesn't even need a role. Now it would just have, yes, and the interesting thing is that it's not a thread that is pushing it forward. It's it's just that when you prompt it, it will just immediately return a list of tasks it wants to perform. And then there's logic inside the agent framework code that executes on each of those. So instead of the thread calling these functions, you rather get back, these are the functions I want to call in order. And you take the output of one function and send it to the next function, and so on. So it's almost like you don't even need threads. You could just have completions. So let me try to write this out. So you don't need like persona or anything like that. What you basically have, you have some input. And this input can be a string or it can be, let's see, let's type, oh, wait a minute. Create agent, definition. So it would have input, which can be string, which means it's like a prompt. Or it can be like a JSON schema, or parameters. Maybe it should always be. Maybe we should just do that. So it's a record of, oh, sorry. So input is a record of string, and what do we call this thing? This one. Yeah, I haven't saved this anywhere. Let's just save it in agent flows, POC. So you have input, and then you define its output. It's the same. It's just a JSON schema. And then you give it functions. And these functions are like, I'm gonna type it completely generically now. Funny enough, not being a generic. And then we're gonna, so this would be the name of the function. And now the thing is, so there's a name for the function and a description for the function. And how should we do this? Well, it should really be the same, a JSON schema. We're kind of blowing up on JSON schemas here. And then you would have like, yeah, how would this work like? So you have this agent. How would this work? So you have these functions, you can give them a schema, but how would you actually act on them? So I was thinking you gave callbacks, of course, to each function so you could execute on them. But now you want that returned result. It's almost like each of the function has an input and an output. And those need to match. So you have an input and output agent. And then you have these functions, and they also have an input and an output. But what's interesting about this is that this function, how would this actually work? Well, I have this idea in my head. It's a beautiful idea. I'm just having some problems getting it out. Because what I expect is that when I call this agent with this prompt, it's going to immediately return. It's going to be a prompt with what are my next steps based on these functions. And it's going to give me a specific output for that, which is like what function to call. But it also needs to know what input to give to that function. And why do I need an output? So So for example, sorry. So what if I have one function? Okay, but we're just gonna give it input and output. Maybe we don't need output. Maybe it should just try to use whatever it gets as output and make that fit with whatever it tries to do next. It doesn't matter. Yes. So maybe what we could do here is we can make this actual callbacks. No, we need an actual schema. Yeah, and I really like that the definition doesn't include the actual implementation. I think that should be... That's a little bit tricky. I'm not sure about that. Like, should the definition include... it makes it more flexible. Okay, we're gonna try without the definition, and then we would do like agent on I guess on function call. I'm just okay. Let's just get some details out, and we can iterate on it. So, and we give it functions. It has input, output. It has functions that requires certain input. So this is the input. And then that is an agent. It's a function with a certain input and guarantees a certain output, and it creates that output by calling these functions. And these functions can be anything. It can be a call to a different agent. Or it can be whatever you want. Makes them very testable as well. The thing is, when I have this function, I don't really have a description of the function. So it doesn't really know what it does. And that's the thing, like, what if it's an agent? You will kind of want to use the description of the other agent. So it's almost like I want these functions to be it should really be input output, I think. Yeah, so okay, so let's say it needs a description. This just describes the agent, and that can be used if other agents needs to use this agent. That description can be used to figure out if that agent should be called. That's basically the reason for the description, is to figure out, should I call this agent? And then you have these functions. Sorry. And these functions needs, yeah, input and a description. And a description. And that means that you could just add like an agent here, I think. Because then it can read the input of that agent and it can read the description of that agent. But it can also be like any other kind of thing, like a function call. Okay. And then what happens here is that this agent it needs to have state. Like it needs to have state in the sense that like, is it stalled? Is it pending with a function call? Did it error? Stuff like that. You need to know that. So it has some state, and then it also needs, yeah, and within that, okay, so let's type that out. Agent state. So that would be status idle. Oops, it's not running at all. That's not really possible, because you immediately run it when you call it, I think. This is what I can't get around. It's like, you wouldn't return it and then handle like the function calls and stuff. You would like create the agent and then you would define what to do. Yeah, so this doesn't quite fit. This is why I think it should be, I'm not sure how to handle this, but it should really just be a promise. So you call it with some input and it returns a promise. And this promise can be so if it's like a nested agent, this promise could be resolved when it actually finishes all its subtasks. Like it shouldn't resolve until it's done, and then you actually get the state of the agent, and that could be like completed, and then you have the related output of the agent on that completed state. But it could also be stalled, right? And then what do you do if it's stalled? So, but then how does it know how to call its functions? That would have to be in the, then you have to pass that in the definition. Hi Adam. I'm just here. I watched a YouTube video. Oh yeah, it was your YouTube video on TaskGen. It was super inspiring. So I just wanted to have some. I wanted to try out a different perspective. So I'm just playing with some API to get my thoughts through. But yeah, so I have. So it's almost like when you define these functions, you would have to on call, like you would have to have the callback here, and then it would be a promise of yeah, it would at least be a promise of something. Thinking. Because if we would do that, then you can implement the full agent here, and when you call it here, it will just return its state. It's being not idle. It can't be idle, but it returns stalled or status is completed or status is error. Stalled just means well, requires user input. That's really what it is. Requires user input. Completed error. well, not necessarily user input. It could be agent input. Requires more input, whatever. Hmm. But that doesn't quite make sense. Like if you have a specific input, I think it's like stalled. Like, does that make sense? So what it would mean is like, what if you had an agent it don't have any functions? It would stall. And then there will be a message related to that. And then you could like prompt it again. But what does that mean for a nested agent? So what if one of these functions is calling a different agent? And then that agent is stalled. Yeah, but maybe this makes sense. The point is, I want this to be like just this hierarchy of agents where things propagate up. And if we can make that work, that will be very, very interesting. So let's say it's stalled, and then it has a reason for stalling. If it's completed, it could have maybe a summary. And also, if there's an error, there's a reason for that error. But it will also have its current list of tasks. So tasks are really function calls. So tasks would be agent task an array, and then you would have, I don't think you need to know which one it's working on because it would just be the last one that's like pending. So you have agent task where the status is idle, so it's not started yet, or pending, or it's completed, or it has an error. And again, you have a reason here, and here you have output, and that output is like the actual output of the function. Agent task, and you would have the same here, of course. And I guess you have the same here as well. So you always have the tasks and the state of the tasks. So that means that the initial state of the agent is, oh sorry, that's not agent task. You also have agent state, sorry. And the status, I guess it needs pending here as well. Yeah, status pending, and then task will be agent task. Okay, so it's pending. Tasks is an empty array currently. It doesn't have anyone because that's what it's going to do now. So if it's pending and doesn't have any tasks, it will be prompt to create some tasks. We're actually going to run this. I'm very curious if we can, like, there's something about this idea of having a minimal definition of an agent, because I feel like these agents are becoming so verbose now, what we have now. And the thing is, like, you really want super focused agents, but what if you could just give them capabilities, ask them to create, and based on those capabilities, they would just be implemented in such a way that when they start running, they're just asked to create a set of tasks based on their capabilities or their functions. And then the code is running each of these steps one by one. And then, as I said, if you want to enhance them, you add more functions, or you abstract them into a new agent, a sub agent. Because you're just learning about like the complexity of what you're trying to do. Because it will suddenly say, I don't know how to do this. It would just stall. I don't know how to do this. And then, okay, let's add a function for that. And then maybe you have like 5 functions, and now you need to add another function, and you see that, wait a minute, 3 of these functions can be their own agent. Let's make that like a sub agent to perform that type of task. And that's how you build it. You just build this tree of agents where it just starts out by not knowing what to do, because you don't have a function for accomplishing a task. That's the thing. Like that's the thing. A function is a task. So when it gets a natural language prompt, the agent is prompt to convert that input prompt into a set of tasks. Yeah. So we have this thing, and the only thing we're kind of missing here is like actually calling OpenAI. So I think there needs to be a higher order thing here, where you kind of you have to give some capabilities to these agents to actually call some model layer. So what I'm gonna do is I'm just gonna create a function, create agents environment, and it basically takes a callback to perform prompting and ask for, and what I also really like about this is that we don't actually use function calling in the traditional sense. It's just we're prompting an LLM, getting a JSON back, and that JSON is initially what tasks it wants to perform, and then we just execute each task as a function call, the function call that has been defined. And that's also just a JSON response at the end of the day. Now the thing is, what if yeah, so that there's one thing, like when you make this call, so you don't know what tasks are going to be, or what functions are going to be called, but it needs to be capable of taking the output of one function and call another function. And how would you guarantee well, you can't guarantee it, but it will actually understand. It will use its context to understand what am I gonna put in the input for this function. So it's almost like, I wonder if we could just, well, yeah, how would that work? Because if you treat a task as like just a function call, you get some output. Yeah, but then you have the next function. Ugh. How would it format that to fit with the next function? So maybe the output of the first function has a certain format that can be like transformed into an input for a different function call, but it actually needs to be the LLM that does that. We can't programmatically take the output of one function call and just send it into another function call, unless they actually match. But maybe that's how it needs to work. Maybe that's how you need to design it. So if you have a set of functions, oh, wait a minute. No, we can return that. Oh, this is interesting. So when we prompt an agent to it's almost like first we prompt the agent to return a list of what it intends to do. What functions does it want to call? And then that's great. It will prompt it to we say that we okay so it returns the tasks it wants to perform, and then it describes how to call the first task, like next task, and that will have like the input for calling that task. And then we call that function, we send back to the LLM the response of calling that task, and then it should now return based on that. Okay, so that means it should have a thread, and then it should, yeah, we pass that output back and say like function call completed, what's the next step? And then it says, I think it should even keep the agents, the tasks up to date. So there's a specific JSON returned from the agent. It's the list of tasks with their state and what's the next step. And if we can make that reliable, then we could just call each function, like it being an agent or a function call, just give that back to the thread. It builds up the context of how it goes through the task, and then at the end it's like done, and we can check that if it's at the end of the and I think we need to do it that way because we could track the execution of the tasks in the programmatically, but we don't know what to input to the next task. Only the LLM is able to produce that. So we need like a flow where okay, maybe let's just make a list here. So what happens is that agent created, whatever the definition is, and then yeah, and then we call agent with input, whatever that input is. Agent generates list of tasks to perform based on available functions. Well, generates maybe we should even call it tasks instead of functions. Well, no, let's call it functions based on available functions. List of tasks to perform based on available functions. Agent returns the tasks and the next task input. So that would be the first task, right? What's the input? But maybe it doesn't even need that. Maybe like since it's a thread, it has its context. Maybe can just ask it to return the next task. Agent returns the next task, next function to call with its input. Yeah. So we do ask it to like create. But but it wouldn't actually create a list of tasks unless we ask it to do so. Returns the list of tasks with the next function to call with its input. And then we programmatically call that, it being another agent or it being an actual function call. And we pass result back to agent and ask it to return, ask it to update task list, tasks and return next function to call. I think that should work. So yeah, that makes sense to me. And then we do rely on, the only thing I'm a little bit unsure about is like, should it keep the state of the tasks? That's the thing I'm unsure about. It would be nice, because then we don't have to keep track of it manually. So it could just be like, we do have an initial pending state because we don't, but then we could, basically it returns a new agent state. That's what I mean. So it basically means yeah, but it's a complicated thing for an LLM to do. So I'm not very hyped on that. I think we need to manually handle it. But to make it actually understand like what tasks it's going to perform, we generate it. So it needs to be part of the JSON, or it won't really have it like in its memory, what it's going to do. But we can rather, yeah, I think what we can do is we'll prompt it with like the functions it has available. It will generate the initial list of tasks to perform. And it will just give like, yeah, so it will have a name and yeah, so it will give a name and idle. That's what it produces. And then it should, based on that list, it should see next task would be name some function and then what the input should be. But that's based on the function schema. Okay, so we will prompt it here to so here we would have create agent. So let's move this up there. So this would be a create agent, and here you would have like the possibility to like create a thread and all of that stuff. I guess we would do the same here. It would be like on prompt. But there's no like on function call anymore. That's just driven internally. I really like that. So now we just, the only thing that is from the outside, the only configuration you need is to send a prompt and return a result of sending that prompt. That's really nice. And as I said, it will never be an explicit function call. So you don't need a complexity of, oh, the LLM is asking for a function call and a response. No, we're going to run this on our own. I really like that. So there's a prompt there, which is a string. And then the result here will always be, well, it's a promise of string. So we'll do the parsing inside here. So this is a generic and definition, and then we have this initial state. Let's move this stuff up here. Okay. Okay, let's see. Oh, what did I do? Oh, look at that. Impressive. Oh, it's still wrong. Oh, of course. And oh, there we go. So yeah, these are going to be generic. Let's just do that immediately. So we have I extend something, and we'll have O extends the same thing. I don't think we really need to So the problem here is this thing. Like in terms of typing, let's put I and O here. So we can infer the input and the output here. But the functions here, we need to have input, but we need this generic to be used here so that we actually get the input here when we call it. The problem with that is that's actually not possible. It will kind of be any, so if we have multiple functions, it would like, you would have the input for every one of them if we make this a generic. Okay, so I think maybe it actually needs to be yeah, I think it actually needs to be an array. Because if we do array, does that help in any sense? No, it doesn't. How would I do that? So how would I, let's just write it out. So const n agents n. And then some agent would be agents and create agent. We have this definition where we say some cool agent, and then input would be a schema, output would be a schema, and then we have these functions. So a function could be, so think about our app, or a coding app. It would basically be, this is where this would be the agent that would get the create me a task management application. So this would be where it actually decides the flow. Yeah, the thing about these agents or this architecture is that it's not very like user interactable in a sense. Um, it's yeah. Well, no, because a function can be anything, right? A function can also be change the state of the application. Um, so what if we already have idea and then yeah, so function would be suggest user stories. And then we say the thing I don't like about this is that I want functions to be I think I need it to be an array. Because then I can just give it some other agent. Yeah. Regardless, I want it to be an array. And we give it a name. Name, input, description. But then it can't have an on call. Yeah, so this is where I'm not sure about the how do you actually act on. So for example, if you were to put like an agent in here. Oh, wait a minute. It could be an agent or a callback. No, it can't be a callback because then we can't describe it to. Okay, but it can be typed as either it's a function, so you create like a function type, an actual function call, or it can be like an agent, and then we can test. And then if it's an agent call, we'll just call the agent. But an agent is a function call, right? Yeah. Yeah, so it's almost like okay. So if you were to kind of put in, yeah. So if you were to put in an agent here, what you would do, since it's just a function call, you could have like suggest user stories, and then you would still have a description here. Yeah, maybe the agents themselves don't need a description. There's something difficult there with the design in terms of the programmatic part and what the information LLM needs. So the LLM needs to know what the input is of an agent. But now I'm currently not, I'm just returning a function. So it doesn't know what the input is. We don't know that here if we were to pass an agent. Because it's just a function call. We need a schema. We could add the schema, of course, to the... So when we actually return the agent, we could have like a symbol representing the input schema and the output schema. Do we actually need an output schema? I don't think we do, because the output is always the same. It's completed tasks. So let's try to make this smaller. And it doesn't really need a description because we'll describe what it does. No, it needs a description. But we have two types here. We have a function call, and the function call is basically this. Has an input, it has a description, and then a callback to actually perform the function call. But then you have the actual agent, and that means that a function call can be either like a function call or like agent. Agent. An agent has its input. Ooh, I don't quite like this. But I don't like duplicating like input as well. Because if we just make it like a function call, I have to duplicate. I have to create a JSON schema that just represents the JSON schema of the input of the agent I'm calling. And that's weird. I already have it. Maybe I'm getting hung up on details now, but yeah, let's drop output. But I do like the fact that it's just the same thing. It's like you could even call it like capabilities. And then you have to define the input. And the reason you have to define the input schema is because it's actually the LLM that tells us how to call it with what information. And it needs a description for the LLM to understand better what this function call does. And when we call it, we'll figure out the typing for this, but we should now get yeah. By the way, I'm gonna try to just fi extends fi, and then input would be fi. Yeah, I'm a little bit unsure here how we would do this. Could we like do t extends fi and then like t here? I don't know, maybe. We don't care about the result. Like the result will be passed to the LLM. But it knows what to do with it. But what I'm wondering is like the schema of yeah. What up? On call. And then yeah, I think this needs to be a function, create function, to get the correct typing here. So you do like create function, you give it yeah, you give it a description, the input, and how to deal with it. But that's I hate this, like where to handle the execution of the function call. Because now if you have it here, you can't like just define it somewhere. You can't define it globally or anything like that. It needs to be defined. Um, it's going to be really hard to see how all these agents are connected. Because it's all just like you have flat set of agents created, and then you have to go into these on calls to figure out where they're actually being called. So it should really be a like a declarative thing where, so as I said, it's like a hierarchy. So you would start with so it will be like some agent. Yeah, it's almost like on call. It's almost like what you want to do is you want to define all the function calls here when you create an environment. And then what you would do here is you don't even need, you could just have this big ass declarative thing. Like initial, doesn't matter what you call it. And it has a description. Whatever. And then you have functions. And based on, like, this is coming from it's almost like you would do agents and create flow. And then you have functions, and these functions can be, no, but you actually have to insert the actual. Well, I guess you could do that. So you can say functions read file, whatever. And that's just based on the function calls you enable here. But then you probably have a shit ton of function calls, and you co-locate all of them there. I'm getting stuck. I'm getting stuck. But so I like creating agents in isolation, because then you can see what it actually does. But then you lose like how does it all flow, right? Because if you then call the top agent, calling these other agents is just part of like a lot of nested function call on calls. So you don't have that. It's almost like you wouldn't even have. This is so interesting. So you have these functions. Blah. I'm not feeling it. I'm not feeling it. So you would have. So what if you had. You could have like agents and create function. Um, so you would have like functions would be not suggest user stories, but read file, for example. Agents and create function. And then you would actually have like a name for it, name, read file. You would have a description. You would have its input, and then on call. Well, you could even have that as like a next argument. So that's how you create functions, and then you can just say functions or even tools. Yeah. Yeah. But I wonder, is there a way to, like, if you want an agent to do something very specific, like what I'm seeing is that there's so many agents and it's so hard to like prompt engineer each one of them. Is there a way to short circuit the prompt engineering? Just like JSON, right? You don't literally prompt how it should return its JSON. There's like an internal JSON schema handling that happens. So you can very easily just say, this is how I want the structured response to be. And then there's like an internal prompt engineering to make that happen. And I wonder about the same for agents. What if you don't prompt specifically what it should do? What if you just give it a list of capabilities? And then there's internal prompt engineering to ensure that it uses those functions to perform a task. And if it doesn't have a function to perform a task, then it errors. So you kind of create this abstraction. Um, yeah, but it's not necessarily to like have zero shot. It's just to, so like you could retry a task a certain number of times, for example, or you could ask it to, okay, for each task you're running, run it 3 times, and then you take the common result, for example. But instead of having, yes, I guess instead of having agents based on unique prompt engineering per agent, um, you have an abstraction. Yeah, exactly. Um, what was I doing? Yeah, and then I would do functions read file, and then I would do do some other agent. Yeah, yeah. I think that's fine. At least to just get a move on with this. And functions is like, I want to change this conceptually. I'm gonna call it tools. Do, 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 do. So yeah, yeah, exactly, and that's what I've been struggling with. I feel my intuition tells me there is a simpler abstraction to be used than what I currently have. Because now I'm like, it feels like I'm hard coding very specific behavior of the agents. Just like having that JSON abstraction over the agents that I have now, there I just have this intuition that there's another abstraction on top of that. Um, that makes it much simpler to make these agents behave. Yeah, exactly. And that's what I'm thinking here. Like, one of the tools would be CSS creating agent. So you have an agent that has a tool, which is another agent that has a more specific purpose. And then the only thing you ask the agent internally is, these are your tools. This is the prompt. What are your next steps? Or what are define your tasks and what is the next task? And then we just call that first tool and gives a response. We give it back to the agent. This was the response of the task. What do you think? What's the next step? And it tells us what's the next step. And then we call another tool. Yeah, but that's what I'm doing here now. Like, I'm not making any difference between. That's why I'm calling it tool instead of function. Is that the tool can either be an actual function call, or it can be another agent. It's just a function call. The reason I'm splitting it up into like input and description and stuff here is because of the prompt engineering. Like, to make sure that the LLM that has a set of tasks passes the correct input to one of its tools, it needs to know what the schema is for that tool. That tool being an agent or just a function. Um, Name, description, input. Mm, let's see. Promise and so on. And then let's see, create agent would just be returning a function where input would be I. And then um, let's see. Let's see. But this needs and I just need an input. Do I need an input? Yes, I need an input. This dissociative identity disorder. That's so interesting. By the way, you should watch a video on TaskGen. So not age. What's the other one? Was it Agent Gen? No. What's the other one from Microsoft? Anyways, TaskGen. It was a really interesting talk. Also, like on how to approach agentic workflows. Well, what's the gist of having dissociative identity disorder? Or I guess it's in the term, like you don't have an identity kind of thing. Let's see. So let's see. Where did I have my agent? So how do we do this? Do we use an interface? And then we can say this, right? Yeah. So it's a promise of any, don't care about that now. And it has like extends. Well, I guess it's a string unknown. And then input is I. But then we can say input. Input is. Oh yeah, wait. So it should still be. I extends this. Oops. I. And this would be. How did I do this? Jason is J. How do I convert it? Oh, output. That's what I'm called. Oh, that's kind of weird. Anyways. Autogen is it? Yeah, I'm using the generics for calling the agents correctly. It's probably overkill. It's just it's a muscle memory of mine. Let's see, agent. Wait, where are your record string? Hmm? Why is it? Why is it I? Doesn't constrain. It's not the same multi-type record string value types. Wait, do I have a nested thing going on here? Oh, record. How did that happen? Oh, interesting. My bad. Oh, did I duplicate it? So it's down here, it's wrong. Do, 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 do. Okay, cool. Whatever input. Yeah, this is also wrong. So this should also be like output. Weird to call it output, but that's what it is. Oh yeah. It is. Everything's like the input is converted to a string, and the output is also converted to a string, unless it's already a string. That's true. That is true. Let's see. I'm gonna do this, and then what I want to do is saying that tools is either, didn't I call it function call? Didn't I put this into a type? I thought I did. By the way, I like type equals this and this. And then type function call would be the other thingy. Would it? No, function call is just a function call. That's the whole point here. No, we have to, yeah, sorry. Type function call would be indeed the same thing as an agent. It's just that, and then it's not like that, it's just output I. And then a tool, where are you? Tools, you don't need this one. So tools will be either a different agent, any, oh, tools should be an array. Well, I guess that can be, do we care about this? No, tools can be an array of any agent or any function call. Oh, or. Yeah. What do you mean, edit itself real time? Array agent or function call. Nice. I think that's kind of it. Yeah, that's all it is. It's just you can create some functions and you can create some agents, and a tool can either be functions read file or it can be some other agent. which it shouldn't be. Like, it shouldn't be the same one. But yeah, the only thing missing is create function should return function call I. Input, definition, input, description, definition. So this is basically just returning the definition. This is only for typing. Let's call this I. You know what? I want to make these the same. Because, yeah, you know what? We can add this. I only need the schema. So I can make this the same, actually. That is interesting. So what if we just rename this to function call? And then both of them will return like a function call. And then we can do this. And then what we're doing here is function call is basically taking the on call, and then we're saying function call input is definition input. Oh, what about the fudge? I need the description. Yeah, but that can be the Oh, so yeah, on the high level, be implemented with the least amount of code as possible. And then to avoid all import and have them resolved dynamically, my tools and agents are made of parts I can create. But that's making a so-called weakness a strength. That's such a how should I put it? Like, those are some of the most amazing stories. It's like when you have this intuition that someone has like a disability, but then turning that around to something really powerful. That's really cool. That is really cool. Oh, that's so such a great perspective. Let's see. So the problem I have now is that this function has a name that I need to use, but maybe that's fine. Like, what I'm seeing is that there's like no difference between, you have name, description, input, and then what happens when. So the only difference between a function and an agent is that a function I kind of want this to be the same. That's super fascinating. I've watched like on TV. I also been following. There's this YouTube channel called what's it called? There's a guy and his girlfriend, and they go and interview people with different kinds of like mental challenges, different disorders, like their goal is to normalize it. Um, what's it called? It's such a great series. Something a book. Uh, I can't remember. Um, yeah, what's it called? But it's I've seen a lot of interviews with people having different like mental disorders. Also, I think dissociative disorder, but it's kind of people have this idea that you kind of completely flip um like there's this way it's fronted on TV like in movies and stuff. It doesn't seem yeah, special books for special kids. Yeah, exactly. Yeah, because it started out as that's what it started out as. Like he was working at the school with kids with different disorders, and they made this book, and then he started this series, and then it's kind of turned into just yeah, as I said, normalizing different behaviors and not behaviors, but disorders, um, and help people understand it. Uh huh. Let's see. Huh, that's so fascinating. Have you had like any like biological explanation of how, or do we know like what biologically happens in the brain, uh, or where it's kind of coming from? It's so the brain is so like that's maybe the coolest part of AI. It's like we're trying to simulate how the brain works, and we don't really know how the brain works, but we know a lot. But there's so much we don't know. Like just people who um, suddenly loses like they get a brain injury and they lose some capability, but then suddenly it comes back in a different region in the brain. For example, like it's so fascinating. That's the cool thing about transformers, having that generic transformer being able to do all these different things. It feels kind of like the brain, like a transformer just has, as I understand, like input and output, and it doesn't matter what the input or output is. It's just a transformer, and then the collection of transformers kind of creates something. But then if some of the transformers broke, you could like make some other transformer do exactly the same thing, kind of. Fragmentation of the hippocampus. Like fragmentation as like a neurological fragmentation, or like more of a physic. I guess that's physical. Or no, but like is everything is like everything there. It's just how the brain evolved in terms of neuro in a neurological sense. Or is it like physically? Yeah. Oh, literally split apart, and you have several coherent set of memories, identities, and more. Wow, that's super fascinating. That's super fascinating. Yeah, I've seen like read about people who actually have like actually has a split brain, which has been like a surgery that's been done uh, on people. I don't think they do it anymore, but like in terms of epilepsy and stuff, they kind of just almost like cut the brain in half, uh, and then when they hold like their left eye, they're not able to verbalize what their right eye is seeing, and if they hold like their right eye, they're not able to draw what the left eye is seeing, like something like that. Yeah, neurological and psychological. That's the temperament of a 7-year-old and like the skill of a 37-year-old. Yeah. You did. uh. Wow, that's dedication. Yeah, exactly. So he never, but is he kind of inside? He never comes out in behavior. Well, kind of behavior, but is it more psychological part of you that kind of drives emotions and like goals, or I don't know how to put it, like drives your emotions and motivations more than like how you act and talk and yeah, being a hacker is badass. I can agree with that. So what's your what do you like contribute with in terms of code? So what does he contribute with, and what do you contribute with? So I guess that he has like the hacking, like insanely driven, figuring out stuff. Is it creative? I guess so. Like to hack Amazon, you kind of have to be creative, I guess. Let's see. I have to. I got a message from my partner. She's like she's been sick since Monday, and I'm still not up and going. And we have these kids we have to take care of. Uh, um, let's see. State of state. Stop. Yeah. Dedication is like you can't do anything without dedication. It's funny how I have a very fluctuating dedication, like, or motivation. I guess they're very connected. Um, like now I surprise myself. Like sometimes I know exactly what I want to do, but I'm not able to dedicate myself to it, even though I know it has a lot of value, both for me and for whoever I'm creating it for, like work related. Um, but other times I'm like completely diving into it. Like I guess this AI stuff for me is like this is like high level of dedication for me. I haven't heard of Dunning Kruger effect. Um, let's see. Just making some comments here to continue later. Let's see. Pending. I want to prompt about functions, about tools, and create tasks. Should output a next task to run. And if it's stalled, I'm not sure how it's gonna get stalled, but it should be able to. Not sure here, but and completed. Oh. Well, it doesn't really have. Yeah, well, we're not evaluating the state here. We're just setting the state. So that would be output. So this needs to be validate task status. This takes JSON schema of tasks and next task. And then we're going to do the task status. Well, yeah, no, it's the status. So if we're pending, we're getting some task status. We'll check that. If it's stalled. Yeah, I'm not sure about this. Yeah, I guess we can do it next week. Do like a hangout if you wanna. I think you can find my email. I can write it here, like Christian Afone Gmail. Well, you have my email, of course. Send me one. If you just send me like an invite next week on a hangout or something, I would love to take a look at what you've been doing. But sorry, I have to go now. But yeah, let's talk more. And thanks for sharing, by the way. I find it interesting and also fascinating and curious. Yeah, all at the same time. Cool. Have a nice day. Bye for now.